Welcome to our fourth CogX. I'm Tabitha Goldstall, the co-founder of CognitionX, and it's a thrill to be welcoming you wherever you are in the world today. I've actually made my way to a co-working space a little bit quieter than being at home. Today, we're looking at sustainable business and how industry is and should be addressing the climate crisis. It's been a big month for climate awareness. Obviously, there's UNGA in the UN General Assembly and UN Climate Week, but also in the tech world. We've had Google make a vow to run all worldwide data centers and corporate campuses on 100% carbon-free power by 2030. And Microsoft and Amazon also invested in carbon share technologies, and another step to achieve this carbon neutrality. So today we will be looking at interesting initiatives like that, as well as really digging into what more will need to be done. With the physical COP event cancelled and COP26 negotiations in Glasgow postponed now to 2021, this virtual meeting that's going on at the moment is incredibly important. And so screens like ours will be buzzing all across, pinging in the background. Screens like us will be buzzing all across the nation and the world. And so we're really thrilled to have the speakers that we have with us today. So with that in mind, the first session will be looking at what a net zero stimulus could actually look like. We have some brilliant minds lined up for you this morning. And don't forget that you can ask them questions as you go along. Tee them up in your app if you have the right membership. If not, store them up for Twitter. And don't forget to check out our expo, where there are some really interesting climate startups that you can go and have a look at. So without further ado, I want to introduce Pete Clutton-Brock, the founder of the International Centre for AI, Energy and Climate. He has some incredible speakers with him today who I'll let him introduce them. So Pete, are you there? Yes, you are. Excellent. Pete, over to you.
Thank you very much, Tabitha, and thank you for organising this event today. It's a really key moment to be talking about this topic, so thank you. So this session, as Tabitha mentioned, is focused on what a net zero stimulus should and could look like. Now, clearly the COVID-19 pandemic is far from over, as we're seeing countries are going back into lockdown, but governments are already thinking about how we can exit this pandemic in the best possible way and support the economy going forward. And as a result, we're seeing huge amounts of money being spent on stimulus packages to help get the economy going again in all kinds of ways. And there has been a strong call throughout the economy for a green stimulus and a green transition to come out of this. Now, how these stimulus packages are spent will likely shape economies over the course of the next decade. So ensuring that they are supporting a net zero transition rather than propping up old industries is going to be fundamental to meeting our climate objectives. And this is a particularly key moment in a key decade, because what happens over the next decade will determine whether or not we are able to maintain global average temperatures to below 1.5 degrees Celsius, which is the global goal. This is, in a way, the decisive decade, because we need to halve global emissions to do so, which is no mean feat, which requires action across the economy. So every single sector across the economy will need to radically reduce emissions. So how these stimulus packages are spent is fundamental to achieving those goals. Now, we've got a fantastic panel to talk about this question today. I'm really pleased to be able to introduce you to all of the panelists. I hope we can bring them up on the screen fairly soon, but effectively, we've got people from across the technology world, from across the policy world, who can talk to this subject in a lot of detail. Now, I'm not going to try and introduce them. They're going to do a much better job introducing themselves than I am going to do of introducing them. So I'm going to pass over to each of them in turn, as well as asking them at the same time to introduce themselves, their organization and what they do, and ask them to describe what they would like to see governments doing with their COVID-19 stimulus packages to support the transition to a high-tech, specifically net zero emission economy. So I'm going to start with Enas. Could you start by introducing yourself and giving a bit of a description of what you do and your answer to the question?
Sure. Thank you very much, and good morning for everybody. Thank you for joining us this morning. My name is Dr. Nasab Hamid, and I am a chemist who turned into an entrepreneur. We focus on the company that I run called H2Go Power. We focus on hydrogen storage technologies for energy storage. We position the technology portfolio that we built and the solutions that we built in two markets. One of them is storing renewable energy for long durations as hydrogen, and the second one is powering drones, and later down the line that solution scales to larger aircraft on zero emission hydrogen, extending power flight times. What I would see as a what we would see that the government could focus on in its stimulus package is how technology companies like us could scale in a reasonable pace to meet the demand that we need to be working at. I think focus on different stages, from early stage development, acceleration, and growth, on especially startups who would compete on budgets of investors, and they wouldn't be very compelling because they wouldn't be revenue generating very quickly. I think focus of government on helping startups like us and others at different stages would really benefit from accelerating the pace to get to where we need to be, especially focus on companies that could grow quickly in collaborations with larger corporates. I think stimulus packages could really facilitate this collaboration and interaction, which could be a lot healthier than funding larger corporates or supporting smaller startups in isolation.
Fantastic, Anas. Thank you very much. That's a really useful way to start this session, talking about how startups need to be supported through the transition. To provide an addition to that viewpoint, Murray, you work for IBM. Do you want to introduce yourself and say what you think governments should be spending their stimulus package on?
Yeah, hi, Pete, and hi, everybody. Thank you very much for inviting me to be on here, and it's a pleasure to be here. And I suppose good evening, good morning, and good night, I suppose, is the right thing to say for one of these forums. My name's Dr. Murray Simpson. I'm the global lead for sustainability, climate, and transition for IBM. I'm also the chair of Tech UK's Climate Strategy and Resilience Council. I've spent the last 25 years working on sustainability and climate across 75 countries with corporations and governments, and I do believe that we have a fantastic opportunity right now. Obviously, we've all experienced very challenging times, and those challenging times will continue in terms of the pandemic, and but we're also experiencing challenging times in terms of the climate. And when we think about the stimulus opportunities and options that we have and the government have, I think what we really want to look at is a holistic view where we're supporting all different aspects of society. Also, we need to support industries of the future and not just of the past. So to get the economy back on track, as well as to actually address the challenges that climate is posing for us, we need stimulus packages that are focused on accelerating transition to two key areas: digitization and the application of AI, artificial intelligence, and of course the transition to net zero emissions or zero emissions. As a company, we do see, as I said, huge opportunities at the intersection between these two transitions. and specifically for applying data science and AI to accelerate the transition to net zero emissions. And as I said, we really need to work together on this. So it's about bringing people together from across technology, policy, finance, and academia to support the coordination and collaboration that's needed to accelerate the adoption of AI for key climate challenges. One important way of doing this that we believe, and we've been involved in, I've been involved in discussions and encouraging government and supporting colleagues both within IBM and outside IBM, and within a whole range of different organisations, including Tech UK, is about establishing an international centre for AI, energy and climate. And this would provide a fantastic base to bring together all of those different elements that I've just described. And if government were to fund and support an international centre on AI, energy and climate, then the UK would then become a hub for a new technology ecosystem that focused on AI for climate, and it would attract international talent, not just around AI, but around climate, around energy, and to address these climate challenges that we all need to deal with. So that would be one of the key areas, and I think there are a range of different activities, actions, and stimulus that would be implemented as a result of that core commitment. So that's something that I'd just like to express to you right now. Obviously, IBM are at the forefront of working on climate risk analytics with climate model ensembles and econometrics. We're also at the forefront of using exponential technologies around the journey to net zero and building a more sustainable future for everybody. So that's what I'd like to say at the moment. Thank you very much, and thanks again, Pete.
Fantastic. Thank you very much, Murray. That was great. And now next year, the UK is going to be hosting COP26, which is the next key climate conference after the Paris Agreement was agreed 5 years ago. Nigel Topping is the high-level climate champion leading the effort to raise ambition from business and other non-state actors. Nigel, could you give a bit more of an introduction to yourself and what you do in that role, and also describe what you would like to see governments doing over the next year to with their stimulus packages to have a good impact on COP26?
Yeah, thanks, Pete. Well, you described my job really. It's quite broad. The role was created in Paris. So, of course, the most important thing that was created in Paris in 2015 was the Paris Agreement. But the countries who are the signatories of the UN Convention also created the role of high-level climate action champion in recognition of the fact that governments can't do this alone. That private sector and local governments and civil society also have crucial roles. So, yeah, I think in terms of the government response to COVID and the role for COP, I think it's important first to remember that I mean, I'm brutally focused on climate and getting to zero, right? But governments have got a real difficult balancing act. They've got to bring treasuries with them, so they can't just throw unlimited money at getting to zero. It's got to be smart. They've got to bring citizens with them. It's a really different political challenge, and they've got to get to zero. So they just perhaps the most important thing is just to send a really clear signal of the end point and the major intermediate point. So we've seen the EU ramping up to 55% reductions by 2030. I'm confident that the UK will present a new and bold NDC before the end of the year. Hopefully that will be significantly more ambitious than the EU. That we've heard yesterday, China now saying that they're going to commit to net zero in the 2050s. And then you need that to be broken down by sector, right? So, a clear phase out of combustion engines in 2030, for example, because those very clear signals unleash innovation, right? If you know as an innovator that there's going to be a market, to Anas's point, if you know there's going to be a market for hydrogen because there's a commitment to trucks being zero carbon by 2040, or decarbonising shipping, which is going to rely on ammonia, which is going to need hydrogen. All those kind of policy signals make it easier to see what the total addressable market is going to be, make it easier to get early stage capital. So that's the most important thing. In terms of winning the political battle, then the other really important thing is a focus on jobs. So there needs to be some very pragmatic things which are like big buildings retrofit programs. And if there's a focus on buildings retrofit and raising energy efficiency, then there's a tech element to that. But most importantly, there's the question of getting people back to work, because millions of people unemployed does not make for a clean transition, because it means the political resistance to policy change will be greater, as we've seen with the Gilets jaunes in France. I think that the other thing I'd say is that we know that technology change always goes exponential. Murray referred to exponential technologies, but the private sector doesn't pile in until the technology is reasonably mature. So investing smart government money in early stage technologies so that we can get down the cost curve enough for markets to pile in. And then finally, things like the Centre for AI, Energy and Climate, what I call purposeful tech innovation. So we don't need more frivolous apps, right? I don't want any young engineers working on Angry Birds 17 or whatever it is, right? All talented engineers need to be working to solve societal problems. And so things like the Centre for AI, Energy and Tech, which put together the societal problem and the technology opportunity, or the work that the UK has done in getting Tech Nation up and running and their work on net zero, because there's a problem with venture capital not piling in enough to solve it. Venture capital tends to focus on software and pharma, and it needs to be purposeful software, so software for solving problems. So that's something I think governments can really help with initiatives like these. Back to you, Pete.
Fantastic, Nigel. Thank you very much for that. Next, we're going to shift back to the startup view from Lucy Yu, who's the Director of Public Policy for Voy Technologies and also an Associate Fellow at the Tony Blair Institute for Global Change. Lucy, do you want to introduce yourself and describe a bit about what you do and your answer to this exam question, if you like, of what governments should be spending their stimulus money on?
Yeah, of course. So thanks, Pete. As Pete said, I'm Head of Policy at Voy. So Voy is the UK's largest micromobility operator, also the fastest growing in Europe. I also work with the Tony Blair Institute, where I lead a project on growth of the clean tech sector. So I think my view is probably quite similar to some of the other two have spoken. I think it's really important that the government invests in skills in this area. We know that COVID is going to have a lasting effect in terms of structural changes to the economy. We're already seeing some of that happening in spite of some of the measures that government has taken. So I'd like to see government put real investment behind lifelong learning and using that to train people in the areas that we know are going to be important for a net zero economy in the future. So if you're somebody who's just finishing education now, you probably have 50 years of working life ahead of you, whatever form that working life takes. Even if you're 45 now, you might not even be quite halfway through your working life. So I think it's really important that government has much more targeted investment around developing those skills and that lifelong learning for these areas which are going to be critical for achieving net zero and beyond. I think I'd also echo some of the previous comments around investment in those innovators, and particularly startups and SMEs and very high growth companies who are working on effectively tomorrow's solutions for a net zero economy. We know that governments have a history of investing in startups and innovators to prime innovation. I think to address the climate challenge, that is going to need to be significantly higher. And I would suggest within the next 5 years, as much as an order of magnitude higher than historically, and then aiming again to double that within the next 10 to 15 as an absolute minimum. I also think that governments need to think themselves about how they can open up the market for innovation in this space. I think government's role is not just about setting targets. It's not just about using tools like tariffs and taxation and developing regulations to support and shape the market. I think they also have a really crucial role to play in their own right as a customer for some of these companies, some of these innovators. So I think that's important. I would like to see many more local authorities, city councils, county councils, really making their own commitments to net zero and then beyond as well. And then finally, I think there is something about infrastructure, and we have, particularly in the UK, we have a lot of very old cities, and they have effectively legacy infrastructure. The infrastructure, the buildings, the roads, all of the systems have been designed around fossil fuel economy. I think if we truly want to enable and encourage this transition, there needs to be a lot of investment to actually move that infrastructure to a place where it can support some of these newer technologies, newer behaviours, and newer business models.
Thank you, Lucy. That was a great series of thoughts from you. Next, we've got Gail Pinson, who is the General Manager for Hub France IA. I hope I pronounced that correctly. I probably mangled it somewhat. But please, Gail, would you be able to offer a slightly more European perspective on what governments should be doing with their stimulus packages?
Okay, thank you very much. Thank you for organizing this panel. So Hub France IA is an association who's accelerating the use of AI, artificial intelligence, for its members. We are mainly focusing on applied AI in all industries and on a European approach to AI, considering Europe has to develop also its specific infrastructure and model of AI to give the world and Europe an opportunity to have alternatives to actual dominant solutions. We are working with our members in 3 ways: through working groups, educational programs, and learning expeditions and networking. We're also focusing on environmental issues in the context of the Green Deal of the European Commission and, of course, of the French stimulus package. This package has been issued at the start of September with a 100 billion euro envelope on 3 main themes: ecology, competitivity, and cohesion. And within competitivity, 2.6 billion are dedicated to what is called support, the support to key markets, health and digital. So this is the context where France is developing the second phase of its AI strategy. The first one was AI for Humanity, launched with a Villani report in March 2018. So this second phase makes it that we expect this AI financing to be totally transversal to all the stimulus package. We are working on the combination of ecology and AI within the European Alliance. I will say more about this landscape project later, but we feel that also for the 2 other packages, competitivity and cohesion, there might be a greener approach through AI. Competitivity, we experience this with our program of the Région Île-de-France for SMEs. SMEs have potential to have a greener activity through AI, and it can be very basic AI. It doesn't need to be technically very high level. In the field of cohesion, the territorial approaches to industry and to AI, we feel they also have a great potential to get greener approaches to economic development and territorial management of resources. So to be also in phase with the things which was said by the colleagues, in the field of AI, we feel the priority is data sharing. So to have as much data being shared to increase the potential of using this data for greener political approaches and greener economic development. The second aspect are the jobs, competences in AI. They need to be developed very specifically because the job market on AI competences is very tight, and this might not fully develop the potential of AI for the environment. So this has to be tackled. And the third point is visibility on AI solutions that can provide and contribute to this effort for a greener economy. And this is where we are working on a landscape of AI startups with our European colleagues, and I might say more to this later on.
Thank you, Gail. That was really useful to have a French perspective on this question. So thank you for inputting that. Just to flag, if any of the panelists want to react or ask questions to any of you, to any of the other panelists, please feel free to think about what you might want to ask any of your fellow panelists. I've got some follow-up questions that we can talk about, but if you this is an open invitation, so please feel free to put your hand up. But I want to nip back perhaps to the issue of hydrogen now, because hydrogen is having its moment in the sun, if you like, in terms of a technology that's seeing a huge boost of interest over the past few months and years. And I guess how we support it is really important. We've seen huge amounts of money coming forward from the EU, from the German and the wider European Commission stimulus packages. But we want to make sure all of that is spent in the right way. In the UK, we're expecting something to come forward in the spending review on hydrogen. Again, as you said, Anas, we want to make sure that it supports not just the big incumbent companies, but also startups in the space to allow for growth companies to come through and drive the innovation that we need to see in the sector. Nigel talked about some of the high-level policy signals that we need to see from government. But how can I want to maybe dig in on this particular question. What policy mechanisms, what approaches, and perhaps this one is for you, what approaches would you like to see from government specifically coming through? How can they specifically support startups in this space?
Well, first, maybe it's really worth talking why hydrogen is important. If we really want a transition into a net zero, then hydrogen is a leading candidate, because what's so interesting about this molecule is that it does not have any carbon, and it carries a lot of energy in it. So when you burn it, you're not producing emissions. So if you are talking about transition to net zero emissions, then that's a really important candidate to focus on. Now back to your question, why hydrogen now is so important, and why we're looking in the direction of startups, and how the governments could help startups potentially in the acceleration process. If you look at software, for example, just to draw a parallel, a lot of the innovation came from startups, and they really changed our world. They did not come from incumbents. And I really think that in energy company that is possible. That is a possible thing to see repeating, whereby you don't expect a lot of innovation to just come from the incumbents. A lot of it could actually come from startups. And what's so unique about the UK is, if you look at academia, a lot of academic or experts in hydrogen and fuel cell in the UK, and that scores quite high against many other European countries or other countries in the US, in the world, the US, for example, and that on its own, a strong academia with this relevant expertise, means that we will see startups spinning out of universities, and that is a case. There are many startups in the UK that they started as a spin out of a research project, and facilitating their growth is extremely important. And I really hope that a hydrogen strategy in the UK in the first place is going to come soon to position how this innovation could be an important supporting pillar in accelerating towards a transition.
Thank you very much. Nigel, you're looking to use the COP26 process to accelerate some of these key transitions. And I think one of the exciting things about your role is you get to dig into these 10x areas where we can see rapid change and look at how we can use the COP26 to really advance support for these areas. How would you describe, perhaps with a bit of a focus on hydrogen, but perhaps AI as well, how can the COP26 process be best used to really accelerate the transition in these areas? And also, how can tech companies such as Enasis and others really help make COP26 a success?
Well, I think the first thing to recognise is really picking up on something which I think Lucy said about going beyond targets, right? So I mean, there's rightly a lot of focus on targets, right? And those clear kind of signals, but to actually start directing capital, you've got to get a bit more granular than we're going to get to zero, or we're going to get to 50% less. So, and I think this is also a changing role for the COPs, right? As we know, the COP is really about three things. It's about the multilateral negotiations. That's mostly done. There's some very important rules still to be finalised. So I don't want to belittle that, but in terms of the private sector, that's less relevant now. Some of the last sort of 10% of the Paris rulebook. It's about national ambition, which is very headline, again, with the Chinese announcement yesterday, and Europe and the UK's NDCs to come this year. But it's also about how do we actually manage these transitions in the real economy, in the private sector, local government, investors, the whole value chain, startups and incumbents. That's the sort of messy transition. The good news is it's an inevitable transition. We know exactly where we've got to get to, which is zero. And all the contention is around timing and pathways. So I think a lot of the work that I'm doing with a lot of partners is about trying to move towards convergence on what those pathways to zero are, sector by sector. Hydrogen's really interesting. I mean, I'd say I'd be much stronger in that. I'd say it's much more than a candidate. We kind of know that we can't get to zero without a big role for hydrogen. If you look at the Energy Transitions Commission, they're looking at a 10 to 15x growth in the hydrogen economy, and of course all of that becoming green hydrogen, so that it's made in a clean way. I think that this is where I think taking a systems view is quite important, because hydrogen is obviously a energy carrier with many potential industrial applications. So a lot of the focus is rightly on the demand side with some of the big projects and big spending, Pete, that you've announced, which will itself stimulate startups and to feed into what might be incumbent-led projects. I mean, you tend to need big balance sheets and big project management capability to run, $100 million projects, but there's a big procurement opportunity there. But also we need to make sure we're not missing the demand side, because we need to generate the demand signals from steel, long distance trucking. You see Volvo and Daimler joint venture on fuel cell technology because they think that long distance trucking is going to be hydrogen powered. Shipping, the Getting to Zero coalition, we're going to have zero carbon ships probably run with ammonia, which is basically a hydrogen carrier, by the 2030s. Gas grids, it's a really good way of generating demand for hydrogen, which actually requires some technology development. If you read Generation H by Marco Alvarado, CEO of SNAM, so there's a lot of the Airbus announcement yesterday, the potential for hydrogen to be playing into the zero carbon aviation, and with I think 14 airlines who form the One World Alliance, all committing to net zero 2050. You've got those demand signals. I think the other thing is we need sort of normative pathways. So we're talking a lot, and we'll be publishing a lot of S curves. Again, Marco says that if we can get to 25 gigawatts of electrolysis by 2025, we'll take the cost of hydrogen down to $2 per kilogram. That's globally game changing. So we need sort of clarity of the size of the prize as well. And then I think that starts to direct VC money to startups once they understand that the world is orientating itself around a big prize, because that's then what excites VCs. Pete, you said that hydrogen's had its time in the sun. Remember, this is probably the third time around, so there's some skepticism. That's why we have to really make clear to everybody that we need a massive upscaling of the hydrogen industry in order to get to zero. I say that ETC provides some really credible evidence of that, which anyone working in a startup in the hydrogen industry can take to the venture capitalists to show them what the total addressable market is going to be.
Yeah, I'd just like to echo that, Pete. It's Murray here. In terms of hydrogen, it's really going to be one of the key parts of addressing the hardest areas of reaching net zero. In fact, what we're talking about here is eliminating carbon. It's not just about reducing carbon and reaching net zero, but part of that picture is elimination of carbon, and that's where hydrogen plays a significant role. And as Nigel said, what we're talking about here is some of the really tricky sectors, in terms of long distance freight, shipping, and heavy industry, of course. There are key industries that we need to be looking at as a society, and particularly in the UK, energy, transport, agriculture and water, but we mustn't forget the importance of industrial and of course, petrochemical. And, we're working with a number of oil and gas firms to help them accelerate their journey on the transition to net zero. And hydrogen plays a significant role in the opportunities around the elimination of carbon and achieving that. It's important to work together in a positive way and not to vilify companies just for the sake of what they've done in the past. It's about the future. And that's why it's so important, and hydrogen is a key part of that future.
Thanks very much, Murray. Maybe just to follow up on that with you, Murray, and one of the things that's coming across from this session for me is that the money that we're going to be seeing coming through from stimulus packages is important and part of the solution, but it's definitely not the only part of it, and we need a much more coordinated approach across finance and stimulus, but also policy and targets to really move the needle in a significant way. Murray, are you seeing any additional barriers or challenges that you think the government should be thinking about in applying digital technology specifically?
Yeah, look, I mean, and I don't want to come across or this forum to be about just beating up government, or pushing government for investment. This is about a combined approach. The private sector has a massive role to play in partnership with government, and I think financial services has a huge role as part of the private sector to be able to make and implement change. But government equally can't sit back and just allow the market to make the difference. So it's about coming together, as I said when I was talking before, about bringing together the different actors, the different stakeholders and different parts of society. Policy design is obviously key, but we need more data, we need more tools, we need accelerators, and we need more coordination on research and implementation of that research. And startups are vital, but equally important are large companies, and those companies that are deeply embedded in technology, as well as those companies that are deeply embedded in society in terms of an industrial position, because they need to change, but we all need to help them change. So I don't want to sound evangelical, but I like to think I'm a pragmatist, but I'm also very much an optimist. And I think we are having the right conversations now. But what's needed is action together, government and the private sector, including financial markets and investment into these areas that are so critical to effect change.
Thank you very much. That's a really nice link, actually, to a follow-up I want to have with Gail on her work, because I think what you've done, Gail, is you've looked to bring together government and the private sector and a range of other actors to really accelerate the adoption of AI in France. I'd be really curious to hear a bit more about the lessons you've learned from that process, what's worked, what hasn't. What lessons would you offer to other countries looking to do the same thing?
Well, I don't know if we can offer lessons, but at least what we decided with some other structures, organization in European countries, is to contribute to making AI transversal to the ecological, environmental measures of the stimulus package. And we decided to do it by working on a European landscape of all AI startups in the field of environment. We believe that giving visibility to AI providers is very important so that their solutions really will be implemented. So we are doing this work with the European Applied AI Alliance, which is an alliance of 11 organizations in 7 states in Europe. We have worked together on a common methodology, which was not easy from the start, with common selection criteria of our startups, a common vision of how to assess our landscape. We will have a third-party expertise to assess our pre-selection, and we will issue this landscape in the coming weeks. By the way, you can look on our site, the EAAIA.com for European Applied AI Alliance. And we found many very instructive existing AI solutions that can contribute to environmental issues. In Germany, a mobile-based app for images, based on images that can show all the plant diseases and stress for agriculture. In France, already AI monitoring cooling units, heating and air conditioning in buildings. In Norway, we found an AI-driven carbon dashboard. In Sweden, we found, based on satellite images, AI-driven infrastructure security systems. So there are many available solutions. We need to make them visible, and we need to have people be confident in these solutions so that they want to use this startup solutions. And that is the role of this AI organizations within the Alliance.
Thank you, Gail. So I wanted to nip back on a bit of a tangent, because often when you're developing these high-tech solutions in different fields, they run into challenges at a local level. And often you deal with not necessarily high-level governments, but often local governments in different situations, especially when it comes to the transport sector. And Lucy, I want to bring you back in here, because what we're seeing is, in the transition to new mobility solutions, we're seeing local governments take on a much more central role in these conversations, given that they have so much influence over the infrastructure involved. Perhaps, and we've talked a lot about the role of national governments and their stimulus programs. Local governments are going to find their budget squeezed probably substantially as a result of the COVID pandemic, and their incomes probably somewhat diminished. What are the challenges and opportunities that you see for local governments to really lead in this area, and are you optimistic about them doing so?
Yeah, great question. I mean, I guess the first thing to say is we certainly have central government, national government, really take the most useful action for us as an industry in actually just changing the law to enable these trials to take place. So that has been really vitally important, actually, just to send those down signals to investors, and to give confidence that the UK is looking at this very seriously. I think just on if I talk about micromobility and e-scooters in particular, one of the things we know, and we've seen from other markets globally, is that the rate of adoption of e-scooters is typically about 4 times the rate of adoption of shared bike schemes. So we already know that shared scooter schemes are reaching people that cycling, for whatever reason, has been unable to reach traditionally. In the UK, we've seen higher early adoption and higher rates of use than in any of our other 45 markets globally. And we're seeing that right across the demographic. Even in our first weeks of operation here, we've seen a very high number of repeat customers, repeat users. And I think that's really important to show that micromobility is a genuine long-term option, and it's not just a novelty. And then also just an observation about the typical journey length that we see with the scooters. They're typically around the 2 to 3 mile mark. And I think that's really important, because that's typically a journey length which people feel is just a little bit too far to walk, and they'll often choose to use the car instead. So that's demonstrated again that this is a very viable substitution for the car, and it has a lot of potential for mode shift, and it's certainly something that we have seen around Europe in the other markets we operate. In terms of the kind of role of local government and local authorities, you're absolutely right. They do play a really critical role here. In the UK, e-scooters use roads and cycle lanes. We certainly have seen some changes to the infrastructure as a result of COVID. So we've seen things like emergency or kind of pop-up cycle lanes created. I think it's really important that some of that infrastructure, which has been created on a temporary basis, becomes much more permanent in its nature, and that will require working very closely with local authorities and investment as well. But I made the point earlier that we have cities that and roads networks which have very much been designed around the car being king. And these are cities that are designed for the motor car. I think if we want to be serious about people transitioning to these greener modes of transport and more sustainable transportation, then we need to make sure that we have an infrastructure which is designed around those modes of transportation and not designed for the car. So it's something that we are working closely with local authorities on, trying to identify, where those areas are, what the infrastructure requirements are. And I think our trials in the UK for 12 months, so we will have a really good sense of what that should look like and what the longer term investment and longer term policy should be, even just a year from now.
That's really helpful. And I think, unfortunately, we're coming towards the end of our time on this panel session. This has been a really useful and interesting conversation for me. Thank you to all of our panelists. We do have another 15 minutes of Q&A with some of our panelists starting at 10, which I believe everyone who is listening will be sent a link to. But all that remains for me to do is thank our panelists for being involved, thank the audience for participating, and thank CogX for hosting this event. I'm going to pass back to Tabitha now. Thank you, Tabitha, for organising this.
Of course, that was absolutely fascinating. I couldn't agree more about making sure that we get all of the brightest, best engineers focused on this as a topic, potentially less angry birds. I thought that was a great comment. And I have lots of questions for all of you panelists. And if you, as the audience, have also got questions and you're watching on the CogX platform, head straight to the Q&A. You've got about 15 minutes to get your questions ready, have a cup of tea, and those panelists will be there to answer your questions. For those of you who are getting ready for the next session, we'll be back here at 10 a.m. where we'll be turning our attention to sustainable industry and specifically looking at the steps that we need to take to get to net zero. So I will see you all at 10 o'clock. Thank you very much. Hello and welcome back to today's CogXtra on sustainable business. I'm Tabitha Goldstall, the co-founder of CogX, and it's a thrill to be welcoming you from wherever you are in the world today. Don't forget that you can send your questions for speakers on the CogX platform, and definitely go and check out the expos and drop a line to some of our brilliant organizations showcasing their innovations. So, how can we build back better? It's become one of the most recognizable slogans of the year. On paper, at least, the UK aims to become a scientific superpower and a leader in green technology. But how do we actually help materialize this ambition? Our next session attempts to unpick these questions, and chairing our panel will be Sharif Asad Ali, Director of AI for Climate for Element AI. Sharif, are you there?
Thank you very much, Tabitha.
Excellent. Hello, over to you.
Thanks so much. And hello, everyone, and good day, wherever you are in the world. So as Tabitha said, we are in a very interesting period of time, of course. And one of the big things we've learned over the past few months is that, as societies, we're not so good at dealing with uncertain risk, even if we know that the risk is very real. And so climate change is going to be a massive risk to our societies, to our economies, to businesses, to every aspect of our lives. And we know that we cannot wait, but we also know that to get to this net zero world in the future that we hope to get to, there's a lot of things that need to happen, a lot of massive changes in the way we undertake our business, in the way we build things, in the way we manufacture things, in the way we run our societies that require solutions that don't yet exist. But we cannot wait. So one of the questions we're going to tackle today is, what can we do today? What can industry do today? And then, so we're going to do this over the first half of this session. And then in the second half of this session, we'll fast forward to 2040 and I think what do we need to have in place then, and think about how we can get there. In my work at Element AI, we are looking at how artificial intelligence can help industry achieve their sustainability goals and move in that direction today. And there's a lot of possibilities, a lot of opportunities that need to be seized. So I'm delighted to be able to introduce to you our two speakers today, and they are absolutely fantastic. There's first Professor Steve Evans, who is from Cambridge University at the Institute of Manufacturing and is Director of Research in Industrial Science and Sustainability. Hello, Steve.
Good morning, wherever you are.
Steve has incredible experience both in industry as an engineer and in academia, and leading research and developing solutions on things like sustainable factories, food systems, and sustainable city regeneration. And our other amazing speaker is Mamta Sinha.
Hi, everyone.
Hi, Mamta. Mamta is a design and manufacturing engineer with 10 years of experience in the global toy manufacturing industry and 7 years in the food and drinks industry. It's absolutely fantastic to have you both.
Thank you.
So, kind of as I said, we were going to start with the first question, and so kind of this is looking at the present. Steve is going to speak to this a little bit, then Mamta, and then we're going to have a discussion between us. So the first one is looking at the present, and we need to reach a net zero world. We need to rethink, redesign, and reinvent many aspects of how we live our lives and our societies. We know that this will take time and money, but we cannot wait. So what can we do today? Over to you, Steve.
Thank you. And what a great question. And I hope to get to it very quickly by hopefully breaking your brain to begin with, because the first thing that we have to do is unlearn some assumptions that we may already hold. Now, I'm sure that you are all super knowledgeable about this subject, so I apologize if you already know this stuff, but I do think it's worth saying. Industry emits about 30% of direct climate change inputs, so the CO2 and the methane and the other gases that create the greenhouse gases. It extracts most of the resources. And that sounds all very terrible until you look around you and you go, I do like living with a table. Well, that came from a factory, right? We like what factories do for us, but we don't like the other bit. So how do we get on the pathway to get rid of the other bit we don't like and retain the bit that we do like? And the first step on that pathway is remarkably simple. Let's learn how to be efficient. And people believe that because factories pay a water bill, because they pay for their energy, they should be operating at absolutely the minimum amount of energy it takes to make whatever product they currently make today. So I'm going to burst that bubble first. You might ask the question, the sort of research question I ask, what is the most energy efficient car factory in Europe? Well, it happens to be outside Derby. It's the Toyota factory. And when Toyota started on a 14-year journey of reducing energy by 8% per annum on average, slightly up and down each year, they were already the world's most famous manufacturer. So when you went into this factory at the start of this 14-year journey, they were world class, one of the best factories in the world. And yet 14 years later, they could make 4 cars for the same energy it took to make one at the beginning. And they did this hardly spending any money. They went and used the brain power of their workforce rather than putting their hands deep in their wallets. We ask the question, what if every factory matched the very best in its own sector? Well, if every factory had the smallest amount of energy it takes to make a loaf of bread, a table, a car, if every factory used the smallest amount of water and materials, they would be 24% more profitable with 30% more jobs and 9% less greenhouse gases. That gets us on the journey that we need to be on. So I'm arguing very strongly here that we should learn to be efficient. I'm wearing a pair of jeans made in a very particular factory. And that factory, when we started working with them, took 800 liters of water to make one pair of jeans. At that time, the world record was 435 liters. We didn't set ourselves a target. We just tried to get better every day. Now it takes 1 liter of water to make one pair of jeans. And that is transformative. That means you can make jeans in any place in the world. You don't need to be next to a river, and you don't need to be next to a river that allows you to pollute it. That changes where we make things. You might ask, what is the best day to make cement? Why did I say day? It seems strange. If you go to a factory that makes cement, each of these blue dots is the amount of CO2 it takes to make the intermediate product of cement that's called clinker. And each of these blue dots is the amount of CO2 it took to make clinker on that particular day. And you can see it varies between 430 kilos of CO2 and 190. Cement manufacturing is the second most CO2 intensive industry in the world. If we, instead of at the average day being here on the 50 percentile line, being about 335 kilos of CO2, we took the 90 percentile day. So that means a day that we can achieve 1 day out of 10 already. And instead of 1 day out of 10, if we made that half of the days, we would be able to save 19.7% greenhouse gases from the world's second largest emitter of greenhouse gases. So let's learn to be efficient. That's my first message of the morning. If only we can become efficient in everything around us, in the way that we use energy, in the way that we use water, in the way that we use materials, then obviously the world will say thank you, and you will become a hero. You might also become immensely profitable, and that's okay too. Thank you.
That's incredible. So much to ask you, Steve, in a little while. And Mamta, can't wait to hear your examples as well.
Sure. Okay, can everyone see my slides? So I'm going to focus on the toy industry because it's the industry that I know the best, and I think it's quite an interesting one. So if we look at our current state within the toy industry, we have a lot of materials, we have a lot of mixed materials and materials that have got batteries incorporated in them. So they're very difficult to manufacture, but also dispose of. So there's not a standard recycling process for the toy industry. Coupled with mixed materials is also the packaging that comes along with that. Within stores, a lot of them are very tangible products with trimes and with systems that allow children to interact with the toy. So that adds another level of complexity to the kind of sustainability journey that these elements might go through. The third part is it's very much like fast fashion. There's a lot of cheap and cheerful products that are on the market that are throwaway toys effectively. You know, the child will play with them for a very short period of time and they'll end up in landfill. So how do we reduce that, bearing in mind the market is very competitive and it's very much based around characters and figures that are this week, this month's season, but it'll go out of fashion very quickly. And also how they're manufactured. It's mass produced, there's a high level of waste, and again, it's generally lower quality materials because of the price point of the product. So you can see, like very much like Steve alluded to, it's about kind of minimizing materials and waste and water and being as efficient as we can. And I think the toy industry is testament to something that does need to be looked at. So I kind of broke it down into 3 elements. We need to really rethink, so look at processes and practices and the people involved, changing mindsets, and that in turn will potentially change how children interact with toys. There's already a lot of legislation and regulations around the toy industry, but actually there's not a lot around compliance as a whole. We need to redesign, so look at less waste, less packaging, and actually how do we reuse? And I know within the industries I've worked in, we've looked at how the packaging could be incorporated in part of the play function. So that actually reduces the overall components of the product. And also reinvent. I mean, as time goes on, children are playing differently. As humans, we're maybe going more digital, we're reusing things. There's also a lot of change material. Lego is a key example of what they're doing with some of their recycled content. And actually, are we going to go back to basic play again and go back to the simple version of playing that is maybe wooden toys or paper-based toys rather than the complex plastic materials that we've got at the moment? Lots to think about there. So if we look at what's out there, there's a lot of time, money, and new technology that will need to be taken into consideration. Again, looking at the trimes, there's a lot of regulations from a non-sustainability angle that toys need to comply with. It's probably one of the most regulated areas that I'm aware of. And also the materials are so complex as well, again, tying in with the regulations around phthalates and chemicals. So looking at some of the work being done by testing labs, so this is a quote from them, that recycling the same material more and more reduces the physical strength of the material, which in turn can actually affect the end user and how the toy is interacted with. So this is a massive challenge for the industry. So we can use recycled content on maybe within the food and drink industry because it is a throwaway product, but actually with toys, we've got to make sure that the end user is as safe as possible. But also we could use toys as an educational tool for children. They are the next generation that will help the current generation understand how to redress some of the sustainability challenges that we've got. So actually, could it be used to engage children in addressing a lot of the key problems and challenges and dilemmas that we've got in today's society?
Thank you so much, Mamta. I think both Steve and Mamta, you've both kind of raised a range of issues with sustainability. And what's really interesting is that Steve, you started with you talked about jeans and then cement, so kind of from very consumer to very sort of industrial business products, and then back to toys, which are again very sort of consumer focused with Mamta, and a different kind of consumer as well. It's kind of obviously children, the way that they choose what they want, and sort of it's a very different dynamic, and I think it brings in a lot of issues around how we market things, the popular culture kind of which you mentioned. And so, I think there is there's quite a bit there. One issue is is cultural and social is one thing, and another is sort of the economics of sustainability. I mean, I think the reality is, if we ask almost any business, with few exceptions probably, do you want to be more sustainable? They'll say yes, of course. Would you like to have zero carbon emissions and zero waste and all of that? No one will say no. But often the issue is the economics. And Steve, you said you mentioned sort of some of the examples that you can achieve something like 24% increase in profits, almost 10% reduce in GHG emissions with some of the approaches you mentioned. But I want to ask you, both of you, if the possibilities are there, whether it's by reducing packaging in toys or other consumer products, or making specific manufacturing processes more efficient, what's the blocker? Why aren't businesses doing that?
Can I offer a question? Two-part answer. The first is the mental model. The hardest thing to change in the world is the way people think the world works. And if you think the world works by buying expensive technology to solve problems, then when you have a problem, you will go looking for expensive technology to solve it. I mean, that's your problem, right? You've got to change. You've got to, if you look at every example I gave, those were empowered people who went looking for small continuous improvements. So one of the biggest lessons manufacturing has learned globally over the last 50 years is that Japanese approach of lots of small continuous improvements, never stopping making small improvements, Kaizen we call it. We need to apply that to water and energy and materials and empower people. At the same time, we need to be looking at what significant technology changes are needed. Because if, for example, as Mamta might mention, if you shift from zero recycled content to significant recycled content when molding a plastic component, that will take money. But what I'm suggesting is you put that money in your pocket by doing the other things first. So very simplistically, engage the brain, don't use the wallet. Keep your hands out of your pockets until you must go there. That's number one. Number two, there's an issue that we call tunneling through the cost barrier. Sometimes when you buy technology, and I'll use the metaphor of the house to keep it simple, the more and more insulation you put on the house, the cost of building the house goes up until you reach the point where the insulation is so good that you don't need to buy or build or install a heating system. And then the cost comes tumbling down and you've tunneled through to a lower cost environment. So if you are half-hearted in your investment, you will be at the top of that mountain, the expensive place.
Super interesting. I think this tunneling through idea is really, really powerful, and definitely something that I think we often don't think about. Mamta, what do you think in terms of like the and you mentioned the packaging, for example, as a one of the things we're seeing is like novel packaging, things that are biodegradable, and these are definitely things that cost money. But what else do you think can be done?
I think a lot of it could stem around regulations within the sector. I think toys at the moment is highly regulated from a safety and compliance point of view. So we really put the child's well-being when it comes to sharp points and edges and chemicals, which is obviously really important. But actually, there's nothing at the moment around recycled content within toys, packaging. There's nothing out there. And if I look at other sectors within, say, the food industry, there's a lot of things coming on board. So I think until there's something that is going to put the manufacturers in some sort of driving position to make change happen, they won't, because it is such a fast-paced environment. It's very, very competitive, and it's all about kind of getting things out there in the market as soon as we can, and not really thinking about the end, kind of what happens after the child disposes of the product or the parent. And so I think a lot of it will have to be in global regulations. And until then, I don't see a lot happening. I know when I worked in the industry, it was never really a topic that was discussed, and I don't see that changing.
Can I offer some hope? No, I think the last 2 years has seen an increase in what we might call virtue signaling. So people making announcements that are very far off. By 2040, our company will become very clean. Well, that's a really easy promise for a current CEO to make. Yeah. But we're also seeing some more serious signaling from people who are saying, look, by 2025, we're going to be doing something substantively different. And I think that as an observer of that system for some period, the noise over the last 2 years has doubled, and the proportion of that I would consider to be serious has also doubled. So the virtue signaling still dominates, but the people who are really taking it seriously have quadrupled. The amount of noise has doubled, and the amount of genuine approach has doubled as a proportion of that. So I'm going to take that as a positive sign. The difficulty is they don't know what to do, right? Yeah. They're making target setting. By 2025, by 2030, we'll do something, but there isn't enough knowledge and experience out there to know how to get on that pathway.
And I think the sad or the complicated thing is we can set these targets for 10 years from now, but whether I'm a brand manager and an engineer within that toy industry, I'm not going to be in that position necessarily 10 years from now. So I'm not accountable for the stretch targets that I'm setting for that business. So it's great because it puts the company in good light today, because the consumer thinks, great, this company X is really sustainable and they're really thinking about the future. But actually, if we fast forward then 10, 20 years, what have they actually done? And I think if we look at other sectors, the changes only happened when people have been held really accountable, and it's kind of gone to the media, or it's been through a legal kind of system.
And how do you see, for example, having metrics or annual metrics of how much you're improving on the previous year? Obviously, to do that, you have to know what the base is and know kind of where you stand today and what your environmental impact is today, and then go from there.
Right, and I think some of that will stem from, I think it's almost having an independent body or a system to measure that, because internally companies can maybe make numbers look different than what they really are, and make, they want to sell a story, and they want to sell their company in the best light possible. Nobody wants to be the worst company when it comes to sustainability, and it is sadly used as a marketing tool if not done correctly. So who's going to regulate all of this? Who's going to control this? Who's going to measure this? If it's the companies themselves, they're effectively marking their own homework, which doesn't feel quite right for me. So there must be some sort of ethical system in understanding what is viewed as a sustainable business.
I give some thought to this. I think that we live in business. We're really keen to use KPIs, performance measures, targets as a way of managing situations. It's a very common management tool. And at the moment, there seems to be a great enthusiasm for a combination of science-based targets and using the UN Sustainable Development Goals. So SBTs and SDGs are very fashionable at the moment with CSR officers. I would like to cut through all of that and just say, last year you emitted X, how much less next year? I would like people just to simply publish, we are 3%, we are treading on the planet 3% less heavily than last year. And let's get on that journey. And it is really simple. We can cut through this crap by just saying, are you better next year than this year? And that's what the planet needs. Not whether it's 1.3 something versus something else. Are you better than you were?
Right.
So first we have to start measuring this and measuring it accurately, which it can be challenging, especially in quite complex supply chains and direct and indirect emissions. But we'll maybe because obviously we will come back later on for a Q&A session, so we'll delve a bit later into this. I'd just like to take us jump 20 years into the future. Hopefully the pandemic will be over by then, so we can get back to that new normal. But I'm not going to ask you to predict the future, because we all know how this goes. It's very unlikely to get it right. But I'll ask you to say what you would like to see in 2040, how you would like industry to have changed, and what are the things that can enable that change. So we'll start with Manta.
So sorry, do you want me to show my slides, or do you want me to?
Yes, please.
Oh, okay, sorry. Sorry, technical error. So fast forwarding 20 years, what will 2040 look like? Obviously, no one can really predict what's going to happen, but we can give a good guess. So I think none of this is a massive surprise to those that are in the know. But I think, as we suspect, everything's going to get a little bit more digital. If I think where we were 20 years before, 2000 and the year 2000, the turn of the millennium, and now where we are, we've really progressed. So 2040, definitely much more digital. Everything's going to be online, but with that comes a lot of ownership and governance and security concerns. We've also got an aging population, so we will see the number of people over 65 go up exponentially, almost. Where we are today to where they predict we'll be is going to be much higher. So how does that change our dynamics and how we interact with people? And actually, there'll be a lot of thought around machine learning and how everyday tasks and activities can be done by non-humans. And will indeed machines be exactly like humans, and we cannot differentiate between the two. So I've got a couple of thoughts. So looking at artificial intelligence and how people can kind of predict how robots can be our friend. And actually, if I think of the toy industry, we're already seeing parts of that happening, but actually that's going to go very fast. And again, looking at machine learning and how things can be done. Will children, if we look at toys or in general, will we work in virtual worlds? And I think we've been forced into that to some extent due to the pandemic. We are in our own little bubbles, we're working remotely, but actually that will be potentially taken a step further. We're actually meeting people will be such a novelty. We're actually interacting with another human in a kind of the way we do at the moment, meeting at a coffee shop, that may totally change, and we may be based in these pods where we just have our own little world. And as before, I think there's going to be a lot of concerns around who owns the data. If everything that we're doing and interacting with is being owned by somebody or something, there's going to be a lot of privacy issues, and even, who knows, our thoughts could be controlled. And And with that, that's not a sustainability necessarily an angle around that area, but there's a lot of concerns about how that data is going to be handled. And then again, the support of the elderly. How do we support them? Will they be contributing the way they are today, and will they be a resource that is a positive or indeed a negative on the kind of the elements that we have? You know, whether they are you know, using up extra water and waste, etc., like that. How do the older population that's going to be growing as the years go on change? And there will be less face-to-face play, so how will that impact children? And if I look at my argument that there's currently a lot of plastic, actually, if things are going digital and things are going online, that might naturally reduce the amount of plastic in general physical waste, and everything will be programmable. And again, could it be that the basic stuff is a novelty? So what, you know, we play with a board game or a toy or internet, that will seem like such a retro thing to do. You know, if I look at people that were 20, 30 years younger than me, for them to look at a cassette player or a VCR, it just blows their mind. They can't relate to it. So what will the population think is interesting? So this was from the New York Post, that we're actually going to spend a lot of leisure time potentially on devices. And if a device like the ones worn by the two individuals in the picture is the way forward, that could be your whole entertainment system. So the amount of waste is dramatically reduced. So for your sustainability journey, it's actually a massive benefit, and it's just a programmable piece. There will be, and again, looking that meeting humans will be the kind of the special thing to do, and that will be the rare activity rather than the norm. Again, focusing on becoming a bit more digital and transformational. Everything will be personalized. We see that with design focused and design thinking, where the consumer is number one, and actually making things bespoke to the individual and personalized. We're already seeing massive trends in remote working, and people predicting where you might be and what your trends would be. So we'll walk away from paper-based models, very much so, to a technical system, people system, where data and predictability is going to be the number one thing to really move people forward. So I've got kind of some trends that I've seen in kind of manufacturing. So IT's obviously going to be paramount, collaboration with robots and machines on a level that's almost like humans, and that will drive efficiency, that will drive less waste, and it will also potentially use less material, because you've not got that human side of general downtime. They can just continue to work. You've also got intelligent manufacturing as well, so they can predict what can happen because they are intelligent machines. So there won't be as much human error, you would hope, and as a result of that, you will be going on that sustainable kind of path where you've got less waste. And with the advancements of material, we're already seeing this within certain sectors, that a lot of the materials that are being used could be biodegradable, compostable. So after a certain time, they will just disintegrate. So actually the waste that we've got within, say, the toy industry again, will not be as paramount, as big an issue as it is at the moment. So again, it will be looking at technology and how that changes, potentially cheaper material, but if those materials are biodegradable or can disintegrate in their own way, then actually it's fine. We can still have that kind of that diversity within product development that we all crave for. Sensors as well, and we're seeing this drips and drabs of this already in manufacturing, that will pick up certain materials and certain components already. So you're seeing that recycled element, and speed of delivery will be massive. and also the data. So the world of work will look very different, and I think organisations will have to look at their supply chain and product development very differently, because we are moving to this world where everything is changing at such a fast pace, and it will be based around digital, new technology, new materials, but also I think engineers and manufacturing experts will be the ones driving the show, because that's where the rules are going to be based. So that's my prediction, but who knows?
Thank you, Ramta. Absolutely fascinating. And there is this really interesting sort of, I think, a balance or sort of two sides of the kind of, when you're talking about gaming, for example, is that on one side you might have this environment that's much better in terms of sustainability, because everything is, or most things are virtual, but at the same time there's kind of these social potentially impacts that we don't and cannot predict at all, that we'll have to watch out for. But also that, you covered a lot of the things that are starting now, things that are in various stages of development now in terms of technology. So I mean, I'm most familiar with AI, obviously, and we're already using it for monitoring emissions, for increasing industrial efficiency. But then you sort of have sort of things that are maybe more emerging at the moment. So some of the new materials that are getting there, that are starting to be commercialized, and there's a whole lot of changes on the horizon if we look at that 20-year horizon. And I mean, a lot to look forward to, but also a lot to kind of be careful about in terms of the impacts we may not consider. Steve, I'd like to hand over to you now, please, for your vision of the future.
Well, I'm a teacher, right? So I've been really sneaky and changed the question to make it easier to answer for myself. So I've changed it to what will 2050 look like? And the reason for that is I've taken part in a number of important projects. So I was one of the lead experts on the UK Government Office for Science Foresight program, asking the question, what will manufacturing look like in 2050? So I'm just stealing from that. And that report was written in 2013. And actually, I'm going to be using slides today, some of which are 7 years old, which is interesting to see how they hold out to what has already happened in the last interesting 7 years. So by 2050, and I think some of this has to accelerate. Some of this has to happen by 2030 because the situation on the ground is getting worse. By 2050, if we don't have a massive global recession, which is still a possibility, the output of manufacturing will treble in value. We are already destroying the planet, but we would like more and more people to have better access to food and the good things of life. So let's see that as a good thing, as it pulls people out of poverty by giving them jobs and by giving them access to product. But it generates impact. So by 2050, every factory would have to be a clean neighbor. So zero local pollution, whether it's going into the air, the water, or the soil. We are going to have to be net zero. We're going to have to put into the atmosphere 0 greenhouse gases by 2050. We're going to have to halve our resource take. Now, some resources, water, lithium, iron, are different in different locations. So that number varies very greatly. In some places, that number is very high. It's 90% reduction. In others, they've got plenty of water in Norway, so their target for water reduction is 0, right? And we got to do that while being fair to everyone and also flourishing, making the world a better place. So if that is the technical challenge, how might we get there? And I spend a lot of my time working with governments and businesses developing scenarios, not predictions, to help them imagine their way forward. And I want to give us one of the little techniques that we might use to get us there. And that is changing the business model. And Mamta was going there with her her toys. Imagine you're a toy company and you have some sort of toys for life contract with a family. And whenever a toy gets bored, you know, I'm now 4 years old. I don't like toys for 3-year-olds anymore. That goes back to the toy company who knows the exact chemistry in that toy, knows how it was manufactured, so they can maximize the recycling value of that. If it goes in your household bin, it goes to your local government, your local council, it goes into a system that doesn't understand the exact chemistry, so they can't maximize the exact value. Imagine that for clothing. So we were working on the problem of fast fashion. Fast fashionistas, as they are called in the UK, are 10% of all purchases, but 26% of all money. And they spend over £50 a week. And on average, their modal use is to wear the main item that they buy once. On average, they have £3,500 credit card debt. So other than giving everyone a frontal lobotomy, which is one possible solution, I'm not recommending it, you could ask them to pay £25 a week to own a card, the 20, that allowed them to have 20 items in their wardrobe at home. But they can bring any of those items back into the shop as often as they like and swap them for anything else that's in the shop. That means you have 2 wardrobes, a very small one at home and an enormous one in the shop. That's fantastic. But the really interesting question is, what does that mean in terms of profit, in terms of cost to the customer? Well, it's cheaper. It's double the profit, and it's half of the greenhouse gases and land use. And that's because the shop understands the garment and the materials. They understand them so well that they can clean them 20 times, and you or I, as a standard customer, would not know that it wasn't brand new. When I wash things after 20 washes, it looks like it's been washed 20 times. That technical knowledge that they hold on the textile and on the washing technology means that they can do a far better job and do it while emitting less greenhouse gases. We need to get on this journey of changing the way that we deliver value to people. Typically, we take something out of the ground, we make it, and we just give it away to somebody and they give us some money. That is manufacturing. That has to change. You might ask a question like, what's the most profitable and efficient car we could make today? Out there right now, you would be challenged to buy a car that is better than 75 miles to the gallon. That's about 4 liters per 100 kilometers, depending on how you measure it. Well, this car is 1 liter per 100 kilometers, is 240 miles per gallon, and it's 10 times more profit than a standard D segment car at the same cost to the customer. How do they do that? They change the business model and the technology, and those things interact. So you cannot buy this car. You can only rent it. Like your mobile phone, you pay per month and per mile or kilometer driven. And they put the petrol in. It's not petrol, but they put the fuel in. And by doing that, the less fuel that they put in, the more profitable they become. And that incentivizes them to get the technology right. People, today, if you wanted, you could go for a drive in a really fun to drive 240 mile per gallon car that's profitable. The world is changing. We need to get a move on. I want to give this very particular example of a project we were asked to study. You may notice that I'm using a particular company's name, Ecover, because it was a thought experiment run by Ecover. They were considering putting a factory on the island of Mallorca in the Mediterranean, where there's lots of tourism. So there's lots of cleaning and cleaning products, which is what Ecover makes, mainly from plant-based materials. But the unique idea about this factory was that you'd fly a satellite over the island every week. That would give you a picture of what every farmer would make. You would add in the weather data, and you could predict that next Thursday, plus or minus a couple of days, Farmer Joe would create about 2,000 kilos of orange juice, but also 2,000 kilos of orange pulp waste. You then take this long list of materials from every farm on the island, You send it to the laboratory and they try to make product from that. I call it the Friday night fridge problem. You know, when you go to the fridge and you try and go, oh my gosh, I got to go shopping tomorrow, but I have to make a meal tonight with whatever's in there. This is the Friday night fridge problem writ large with amazing science. The scientists at Ecover can look at those wastes and say, if I take Farmer Joe and Farmer Jane's waste, get it into my factory, I can make and fly the enzyme I need to convert that to shampoo. Nice idea, eh? Don't pay for your raw materials. Now, we call that a foraging factory because it forages. Factories will look around themselves for their input materials. They won't look for a mine that is 3,000 kilometers away. And if you look at this rather complicated picture, this is a picture I did for the UK government, looking at how digitalization will interact with sustainability through to 2050. And near the top right-hand corner, you'll see this phrase foraging factory. And it's one of the technologies that we believe will form the third wave of use of digital technology as digital technology supports the move towards sustainability. The first wave is to do more with less, i.e. being productive. The second wave is to allow companies to be strong during disruption. Wow, that's quite important right now. And the final wave is actually to live within planetary means. Now, I'm not going to go through the details of this, but there's some interesting ideas in there. Happy to share at other times. When I was one of the lead experts writing that report in 2013, and we finished writing the report, I wrote this slide. This slide is 7 years old, and it was a prediction of the journey from 2013 out to 2050. And it suggested the first wave would be business as usual, with a growing focus on efficiency, as in energy, water, and material efficiency, not just labor efficiency, and with a hope for a growing market. And when we looked forward, the government asked us to look for future disruptions, and we found so many of them, it scared us. And we came to the conclusion as a group that the second wave of change that's going to happen to manufacturing globally is to be ready for a period of disruption when the materials flowing into your factory and the products flowing out are under a rapid change. So we believe preparing for periods of disruption, being resilient, is the second wave. And you can see that already happening. And inside the box are specific things that might happen during that phase. We are nowhere near the third phase, which is new structures and governance. The rules of the system are going to change. And I'd better finish by telling you that by 2050, the factory will be at the end of your street. It'll be making things for you, personalized, that are based on the waste from other systems that are also in your street. It might even be in the library. And in that world, I want to live. Thank you very much.
Thank you very much, Steve. Absolutely fascinating. Just everything about the kind of that last thing about the factory at the bottom of the street is amazing, and also the prospect of maybe we inspire some people and we'll have some clothes as a service and toys as a service businesses popping up soon. Thank you all very much for being with us today. Just to remind you, there is a Q&A that some of you will attend in just over 10 minutes.
Thank you. That was absolutely awesome. I certainly will start engaging my brain before my pocket. So that was really very useful. As Sharif said, you can head over now to the Q&A, which will start in 11 minutes, or you can stay right here and we'll have our next session starting at 1 o'clock. So I will see you at 1 o'clock. Have a good lunch. See you soon. Bye. Hello and welcome back. Today, we are looking at sustainable businesses and how industry is addressing the climate crisis. I'm Tabitha Goldstall, co-founder of CogX, and it's a thrill to welcome you wherever you are today. Don't forget, you can send your questions into our speakers on the CogX platform and check out the expo and drop a line to some of the brilliant organizations we have showcasing. This next session is called Building a New Economic Future. With pioneering lab to market innovation, we have a chance to rapidly reform and build alternative industrial models that no longer rely on the fossil-based resources. Your chair today will guide us through this conversation. He's called James Talentier, the Communications Manager of the University of Manchester. James' connection isn't so great, so if we lose James, Adrian Nixon, the editor of Nixine, journal specializing in graphene and 2D modeling, might step in. But let's start with James. Are you there, James?
I'm still here, and while I'm here, everyone, hello to everybody. Hi. If you lose me, I do apologise now. And so, yes, hi, welcome everyone to our session, Building a New Economic Future. I guess part of the title reflects the phrase "build back better," which I think many of us heard recently, and this idea that we're in this pandemic, COVID-19 pandemic, this global crisis, but from which maybe we can look forward to build a new economic future and then seriously tackle the big challenge of climate change itself. Today, we'd like to look at two themes really within that proposition. One is about reforming, rebooting existing sectors, manufacturing, aerospace industries, the auto industry and their supply chains. How do we make them better? And also about revolution, doing something very different, building and making things in a different way, or at least to a scale that's never been done before. And to help me with that conversation, I have a panel of some excellent experts, journalists, academic leaders, innovation leaders and entrepreneurs. I have James Baker, Chief Executive of the Graphene at Manchester, Adrian Nixon, Editor of the Nixine Journal, Professor Rob Field, Director of the Manchester Institute of Biotechnology, and two entrepreneurs, Dr. Vivek Koncheri, Chief Executive of Space Blue, and Dr. Binish Siddiq, Chief Executive of AEH Innovate Hydrogel. Hi, colleagues. I'll just let you do some quick introductions. You can do it a lot better than me, and then I will come back and ask a few questions of each of you, if I may. James.
Hello. So good afternoon, everybody. I'm James Baker, CEO of Graphene at Manchester. So graphene, the wonder material, first isolated in Manchester 2004, sticky tape and some graphite. You can all do this at home to create graphene. Nobel Prize for 2010, but I'm going to talk today about is how we take that great science from UK universities to create new products and applications in a way that were never achieved in the past. Look forward to speaking.
Adrian, please.
Hello, everybody. I'm Adrian Nixon, the editor of the Nixine Journal. We're a relatively new journal. We set up in 2017, and we create a monthly issue looking at the technical and commercial developments every month in the world of graphene and 2D materials. This whole field is moving really fast, and we're creating a 50-page issue to brief decision makers in industry and also academia, just to keep up with the pace of change. We're now in volume 4 of our monthly issues. We have a subscriber-based model, so we don't take advertising, so we like to think we're completely independent. And if you look at our YouTube channel, Nixine Publishing, you'll find lots of free source material out there as well.
Brilliant, thank you, Adrian. Rob.
Hello, Rob Field, Director of Manchester Institute of Biotechnology. So we are a university-based discovery innovation institute, which is very much industry-facing. So we're really looking to see how we can take the academic ideas of today and turn them into the commercial realities of tomorrow. How can we build those pipelines, setting up companies to de-risk activities, and then on to the bigger companies that would allow us to roll out at scale. So exciting and interesting times, but also challenging just at the moment, but that presents some new opportunities.
Absolutely, thank you, Rob. And then Vivek.
Hi, I'm the CEO of Space Blue Limited, a startup based in Manchester. I invented and developed a graphene-enhanced recycled rubber floor mat. This mat is actually made with waste car tire and graphene. One of the biggest challenges when you recycle any material is performance drop. thanks to graphene and working in collaboration with Graphene and Manchester, we solved this problem. We are starting the commercial sale of this mat next week on Tuesday through our website, www.spaceblue.co.uk. And we need your support, and together we can make a sustainable world.
Thank you, Vivek. Brilliant. And then Beenish.
Hi, I'm Dr. Binish Sadiq, CEO and founder of AEH Innovative Hydrogel Limited. Our company mission is to help indoor growers and farmers to grow crops in cost-efficient and sustainable way. Just recently, we have secured 1 million Innovate UK grant, and now we are working in Geek to develop this product and bring that product into market.
Fantastic. Well, thank you, colleagues. And if I may begin with some questions, and I will start with James. James, I mentioned we face these existential challenges, COVID, and of course, the big topic of today, climate change. Now, Manchester's famous as the home of graphene, big expectations on this so-called wonder material. But really, how can this nanomaterial help existing sectors go green at a global scale?
So just building on the great introductions from the panel, 2004 sticky tape and pencil to create graphene, Nobel Prize in 2010. But one of the challenges we have is it can take many years, if not tens of years, to take a new material from the lab into products and applications in the marketplace. So whilst I talk a lot about graphene today, graphene is just one of over 100 two-dimensional materials. If you like, it's part of a broader advanced materials agenda. And I'm a strong believer that advanced materials will play a key role in terms of meeting some of the key challenges we have around sustainability. In the UK, carbon neutral by 2050. In Manchester, carbon neutral by 2038. But interestingly, just been on a webinar this morning. To achieve 2038, we actually need to be building green construction by 2028. Otherwise, there's huge retrofit that we needed in the future. So what's the role of advanced materials? Graphene as an example, in the literature, from the science, it has properties like 200 times stronger than steel. It's more conductive than copper. It can act as a perfect membrane. It's flexible. It's transparent. But the challenge is how to get some of those real properties into actual products and applications. And in Manchester, we have our National Graphene Institute that's focusing around the acceleration of the science, bringing the physicists with the material scientists, with the engineers. And we have the Graphene Engineering Innovation Centre, a catapult-like building, part of the University of Manchester that can really accelerate, if you like, make or break, take these new ideas and these new concepts. And we can make everything from graphene into rubber, through to graphene into carbon fibre, for example, into lightweighting. To achieve some of our sustainability targets, we need lighter, greener aircraft that can fly across the Atlantic without emissions, without fuel. To do that, they need to have batteries, they need to have hydrogen fuel cells, they need to have lighter structures. Through to our cars of the future, our buses, maybe it's a combination of a battery with a supercapacitor. So all these areas of challenge around sustainability, of carbon neutral, graphene advanced materials can play a key role in that. But the business model we need is very much one around collaboration, working with large corporations like Airbus or Rolls-Royce, through to working with government and agencies like Highways England. We're looking about putting graphene into roads so that we can have a road that is both more durable and tougher, but it also doesn't create cracks that turn into potholes in the winter or in summer. Again, one of those challenges that will be key if we're going to get our infrastructure and productivity, more sustainable in the future. So a key to that is very much around collaboration. Adding a small amount of graphene into a product can make a big difference, and you'll hear some examples later, from batteries, energy storage, through to lightweighting, through to water filtration. In the future, we could potentially have a graphene membrane where you could take dirty, salty, contaminated water through a graphene membrane into drinking water. So the Geek is very much around that collaboration. We're working with over 70 companies in Greater Manchester, small and medium enterprises, from startups to small existing businesses, and you'll hear from a couple of those later today. So for me, the answer to your question, James, is very much that graphene advanced materials has a key role, but we can't work the way we have traditionally and take 10, 20 years for new materials to come to the market. We're going to look at new business models, new collaboration models, but also how we really accelerate these new ideas and concepts into products and applications. And that's the opportunity I believe we have through graphene and advanced materials and this broader agenda of materials and manufacturing in the UK.
Thanks, James. That's quite a vision, and thanks for outlining that so well. Adrian, may I come to you now? Now, James there has that big vision, and he mentioned some things like infrastructure, etc. If I may, and can I just say I am a bit of a reader, a bit of a fan of your journal, and full of fantastic information. There's one article, actually, one study I think you led on, which really struck me. Picking up the points of James there and application, it's around adding graphene to concrete. And if I understood this, you're suggesting through the supply chain, you could end up with a reduction of about 2% of global CO2 emissions through that. Could you explain more? That does sound extraordinary.
It is, and I think that's an underestimate.
Right.
Just before we start, when Nobel Prize was awarded for graphene, people thought it's going to change the world, and then all of a sudden they realised they're just getting, this is graphene, they're getting black liquids and powders with a powder, and people thought, oh gosh, this is really underwhelming. It's not really going to do anything, and graphene started to sort of get labelled with hype. And since probably over the last sort of 3 or 4 years, we've started to see graphene definitely coming out of the hype, and we've been monitoring different applications. One of which was graphene powders and liquids put into concrete. And when we started to look at the results, we just went, wow, people really need to know about this. So we took apart a lot of the literature that was being published, and we looked at what people were actually doing with graphene in concrete. And graphene, by the way, graphene is applied in all sorts of different areas. This is just one niche of something that graphene can do. So we took apart all the different studies and we put them together in a summary, because we try and create a summary on 1 page per topic for the journal. And the way we summarized it was looking across a range of peer-reviewed tests. And we found that on average, about 0.03% of graphene powder increases the compressive strength of concrete by over 25%. Let me say that again. 0.03% graphene increases the compressive strength by 25%. That's a quarter increase. Things like this are unheard of, and that's a vanishingly small amount of graphene. So what that actually means is, if you work backwards, then you need to use 25% less concrete for the same amount of strength. And then when you start to unpack that and dig in a little bit, we looked at how much global cement production accounts for global CO2 emissions. And Chatham House, which is a fairly reputable source, they reckon that cement production accounts for around about 8% of global CO2. Take a quarter off that, that's 2% of global CO2 emissions. Almost, you wouldn't really notice. I just happen to think that is absolutely staggering. That was a year ago. Since then, only last month, because again, this whole field of graphene and advanced materials is moving so fast to keep up. Last month, there's some work done by a Geek Tier 1 partner, First Graphene and the Australian Research Council at the University of Adelaide in Australia. They've done some more work showing that the compressive strength is actually increased by 34.3%. The tensile strength is increased by 26.9% just by adding 0.01% weight for weight graphene on concrete. And that is some peer-reviewed test results already. So this stuff, we thought this needs to be got out into the outside world. People need to start really paying attention to this, because there are challenges. Maybe some of the Q&A might pick up on some of this. But boy, the benefits of trying this are going to be absolutely irresistible. That's just the tip of the iceberg, James.
Yeah, Adrian, that is an amazing case study, I have to say. I think the point there is what a tiny amount of this advanced material can do to make such a transformational change. So, you know, you think, why is this not done sooner? But I guess this is where we come into it now. The COVID catalyst, we can do things different now. Seize the day, I guess. Is there enough graphene, by the way, Adrian? Would there ever be enough graphene for the kind of scale you're talking about?
Is there enough graphene? Oh, blimey, that's a very good question, actually. Andre Gein, the Nobel Prize winner, asked the same question a little while back. You'll probably remember. So you're in good company asking a question like that. As a result of him asking that question, I've sort of gone into the numbers because it's actually quite a valid question, because we're talking about billions of tons of cement production. So even 0.01% graphene is going to be quite an amount. So when working through the numbers and looking at the first graphene data, we reckon that we've run a few calculations and say there's around about 2.8 million tons of graphene powder required each year. Now, graphene is made from graphite primarily at the moment. So we looked into what the global graphite reserves are, and there are around about 800 million tons of graphite reserves in the world that we know about already. So if the economics go up a little bit as well, we'll probably find that's an underestimate. So just in terms of graphite itself, then there's going to be plenty of supply out there. And maybe something else we could possibly pick up on later is making graphene powders and liquids from graphite is just one way. There are actually some other ways of making graphene where we could liberate even more graphene. So I'll park that one for the minute because I'll open up a Pandora's box of information that we'd all dig into.
As ever, Adrian, yeah, there's always a Pandora. Yeah, you open those floodgates of questions, but fantastic. So basically, what I'm taking from James Baker, what I'm taking from you, Adrian, is advanced materials, in this case, graphene, can absolutely transform what we've got already. Existing sectors, existing ways of doing things could be completely changed and meet the climate change challenge head on. Yeah. If I may, I'd like to bring in Rob Field now, because Rob, his field is biotechnology. And it seems to me, Rob, and you can correct me, but it seems to me your field could actually be the revolution as well. It could bring something that we've never quite had before, the biomanufacture, actually moving away from these fossil-based resources and do something quite different. Could you expand on that?
Yeah, sure. I mean, I think we're at an interesting time at the moment. I think a lot of the industry, a lot of the products we rely on in society are heavily dependent on the oil-based feedstocks, something we're going to have to move away from. But it's not just about feedstocks as such. There's so much more when it comes to manufacturing. There are all the waste streams to be considered. There's also the question of where do we get the energy from? And increasingly, where do we get the water from as well? So there are a lot of factors there to come to play. Biotechnology has opportunity to impact across quite a wide swathe of different activities, whether we're talking about production of food and biofuels, bioremediation. How are we going to generate the next generations of advanced pharmaceutical intermediates, vaccines, diagnostics? And then there's the fine chemicals, the biodegradable plastics, and sustainable materials in a broader sense. So biotechnology is a very broad church, and it could have an impact on all of our lives in very different ways. How are we actually going to realize that impact? So if you look back actually over a century now, where has biotechnology really transformed healthcare, for one example? So if you go back to the 1920s, you'll come across an academic lab that uncovered the production of penicillin, a nice academic curiosity that sat on the shelf for 20 years before anything really happened with that. And it wasn't until the 1940s that biotechnology processes really drove the industrialization of penicillin production, making it readily available. Now, of course, the 1940s was World War II, and it was in fact that global strife that drove the necessity to do things differently and not just do more of the same. So that was the coming together of academic curiosity and creativity with the pragmatism that comes from industrialization, commercialization, to take things through from that minuscule scale that you would get in an academic lab to what is necessary for rollout for societal impact and benefit. So one of the lessons that's been learned over the years, and certainly something that the Manchester Institute of Biotechnology is focused on, is that co-creation of research and development activity involving the academics and the industrialists at an early stage. Within the Institute of Biotechnology, we have the Future Biomanufacturing Research Hub, which is populated with the academics bringing their bright ideas to the fore. But we're working on real world problems brought to us by industry, the things they can't deal with at the moment, the things they know they're going to be under pressure from government about in terms of their waste streams, for instance, and their environmental sustainability. So that co-creation, echoing what James was saying, is absolutely key. You need to work closely between the academic creativity and the industrial pragmatism and realism if you really want to take something from idea to scaled impact. So trying to find new ways of working there. Within the MIB, we have our academic labs. We have some labs which are co-funded by academic funding and by industry, but are still based on discovery. And then we have the more pragmatic rollout as well towards that early scale of what's referred to as the valley of death. The bit that's difficult for the big companies to buy into because it's still a little bit risky, they're a little bit unfamiliar. We're entering into that phase of starting to de-risk the processes of tomorrow so that they're less of a problem for the big established industries to take them up. So we need quite a portfolio here, and the challenge that's facing is not just around COVID, but it's not only the challenge, there's the opportunity too. Brexit coming up, we need to be conscious of our supply chains for pharmaceuticals. We need to be conscious of our food security. So creativity in these spaces is absolutely critical going forwards. Because of the timelines on Brexit, the pressure to do it now, to do it yesterday, and not in 20 years' time are paramount. So these are exciting times for biotechnology. There are huge opportunities here to move away from the oil-based feedstocks that we're used to, the industries as we know them, the large chemical plants, and to move into something that's more sustainable. So that's absolutely on the agenda, part of the Manchester ethos.
Well, that's fantastic. That's beautifully articulated there, and quite a vision again from yourself. Just to pick up on a point there, this notion of valley of death, scale up, and translating knowledge, ironically, like graphene, penicillin, whatever, curiosity in a lab, and how do you get all that into the real world? Perhaps our next two speakers are part of that delivery. We have, well, first of all, there's Vivek Concherry. If I come to you, Vivek, so basically, I mean, you are very much part of that the supply chain there that Rob mentioned is important to you as well. But first of all, if I understand it, Vivek, your spark into entrepreneurship is partly due to this knowledge, this realization that old car tires from the UK were shipped off to India and then set fire to, talk about climate change challenges, only how to contribute to it. So you decided, I think, to do something about that. So as a business, what did you do, and how ultimately will your supply chain work, do you think, in your business?
I just want to highlight, waste tire problem is not just a UK problem, even though it's 100 tons a day in the UK. Just to give an example, in Kuwait, waste tire graveyard can be seen from space with 7 million tires. So it's a massive problem. So just to catch up on what I learned from the whole journey of in finding product in the lab all the way to market is global. I mean, with the current COVID, global economy is at a crossroads. And traditional model of growth, economic growth, without the concern for environment won't work anymore, as well as carbon inequality. So we need to retool our growth towards sustainable product. To solve, waste tire is a massive problem. To solve this problem, it's a collaborative effort. There are many parties. First is manufacturers, then there is consumers, then there is government and innovation centers. Just to bring as an example, as a manufacturer of a sustainable product, we are focusing on local manufacturing for the local market. This doesn't mean we have no global ambition. We do have global ambition. So for an example, for the US market, we will make in the US using US waste tire. So but to solve this problem, we need consumer support as well. Sustainable products is no more a luxury for the few. It's affordable to all. And it's the choices we make. And thanks to advanced materials such as graphene, you don't have to compromise for the performance as well. We can optimize the performance of the recycled products using graphene. Governments also have a part to play. Just to give an example, producer responsibility regulation, which means a manufacturer is responsible for end-of-life recycling. If you add tires and more product into this category, then manufacturers will choose the right material to start with rather than companies like us dealing with a big problem in the end. It's like 250,000 tons UK is shipping abroad. And most important part is innovation centers, such as an example is Geek. They need to lead the way. They need to show it to consumers that something is possible. just to give an example, if Henry Ford asks their customers what do they want, all the customers will tell him, I want fastest horse. So till the centers like Geek show it to the people, something is possible, people won't come forward. I mean, thanks to Nixon publications and CogX, now we are spreading the news, what's happening in the wonderful innovation centers, and especially in graphene, how it can change the world and make a sustainable future. One more thing I would like to say, like James Baker said, is fail fast, learn fast innovation model. Because world is moving so fast, we need to do something now. The current problem it's not a problem, it's a crisis. So we need to act fast to solve such a big problem. So what I think is to solve, together we can make a sustainable world, and innovation centers such as Geek need to lead the way. Thank you.
Thank you, absolutely, and it's interesting that the one theme that is coming through is this acceleration. You know, innovation is great and great science is good, but unless that's fast-tracked into our world now, we're not going to meet the policy demands. We're not going to meet, the challenges ahead. So that seems to be a critical point. And then, Beanish, again, another entrepreneur, another great vision. So your business is part of your business is associated with agriculture, a point that Rob picked up on earlier. Agriculture is obviously a very important sector. And this notion of vertical farming, which sounds very interesting, this kind of urban farming, which is in itself an exciting idea. Now, you have an innovation that's going to actually transform that. And also, I think part of that innovation and some of the funding you've had from government is all about supply chain and supply sovereignty. Again, a point made by Rob earlier. So please explain.
Yes. So basically, firstly, I will highlight a few issues with control environment agriculture and then just go with the solution. So by 2050, there will 80% of food consumptions will be in cities, but for this controlled environment agriculture, in simple terms, I will use like growing crops or vegetables without using soil will play a vital role. But there are certain issues associated with controlled environment agriculture. Number one is higher operational costs due to energy consumption demands, and then second one is higher water usage. So this is basically to tackle these issues. We need to develop some kind of system that will enable growers to grow crops in a cost-efficient way. So, for example, one of our customer, a potential customer we are closely working with, they produce baby spinach for 26 weeks for you to supply to UK retailers. But the UK demand for food supply or for baby spinach is for 52 weeks. With controlled environment agriculture, they managed to produce for 26 weeks, but not for 52 weeks. So what we are doing, our business is developing a solution that will enable indoor growers to grow crops for 52 weeks without basically without using higher energy or water usage. So overall, our aim is to enable indoor growers to reduce the food mileage from farms to the plate. So that's it.
Great. And as I understand it, part of this will help with supply chain sovereignty, that we could actually do more growing, more agriculture, or more productive agriculture, should I say, on our own shores. It's that point I think Rob was making about Brexit, COVID itself. It's shown us that we need to do something different with the supply chains. Is that part of your model as well? This idea that we could do more in our own, whether it's UK or wherever, is that something that's very important to your proposition?
Yes, so our idea is basically to help indoor growers to grow like crops in cost-efficient way without so that they can supply the food to UK retailers for 52 weeks or for whole year, rather than just producing food for like 26 weeks. So this is the main idea.
Fantastic.
Yeah.
Thank you. So, okay, so some things come from there, and if I may, I just may revisit some of the speakers again. So, I think I might go back to the start there with James. So, one thing is coming clear is that it's how do you accelerate this change? How do you make things faster? I mean, Beanish has got quite a bit of funding from government, for example. What's the best way to do this? Is place important? Is it a grassroots thing, innovation, or should it come top down? Should government be pushing it? How do we work this? Do you think, Joe?
Gosh, it's a very broad question. I think Rob touched on it.
Sorry.
Traditionally, innovation, can take many tens of years for a new advanced material from the lab to the marketplace. But we've all come accustomed these days to some of the changes from software, through apps on your mobile phone, etc. That why does it have to take so long for a new innovation to come to the market? Now, advanced materials aren't as simple as software or an app. There's a lot more work to do. But to start to answer your question, I think we need a mixture of government policy. So if I look at graphene as an example, we've had government policy that's been supportive of building the National Graphene Institute, 61 million facility in Manchester. Also, we had 30 million from UK government out of a 60 million graphene engineering innovation centre, and also investment into universities around Henry Royce and around fundamental research. So government support of research, again, just to remind the audience, graphene was first isolated based on curiosity. We actually allowed some of our academics some headroom to investigate unknown things. It wasn't driven by a commercial imperative. Interesting around the penicillin earlier. So not always driven by a commercial imperative. That fundamental science in the UK still has a leading position in that. But for me, as well as that government intervention in terms of facilities, infrastructure, research, we need a new business model of collaboration with industry. We can't afford to wait necessarily for tens of years for that innovation to come to market. We do need that intervention, that partnership, that collaboration with industry to create supply chain, to create graphene as an example, not just by the gram, but by the kilo, by the ton, to use Adrian's example. So the business model is key, and Manchester around graphene and around MIB, we're developing these new collaborative business models, academics with industry, to try and accelerate the innovation. I think the other thing, and the World War II example was great, but I think now environmental sustainability, with COVID, I thought innovation might slow down because of the global crisis, the inability to meet with people. But thanks to these great platforms like Zoom and Teams and initiatives like CogX, for me, it's actually accelerated bringing people together to talk about innovation, to talk about challenges. Providing we can keep our facilities open and we can start doing the experimentation, I'm actually seeing a big acceleration in innovation and ideas. We're talking to partners now who we started maybe a month ago. Through days and weeks, we've done a series of meetings, brainstorms through WebEx. And these aren't just in the UK, they're across the world with designers from America, China, different regions of the country. And we're now kicking off projects, and we hope to launch early products in early next year. I mean, Vivek hit the nail on the head. With sustainability, we can't afford to wait. I'm from an aerospace background, and aerospace are now talking about carbon neutral aircraft by 2035. Now, if they work conventionally, I would argue the aerospace sector should have started that program at least 10 years ago. So they have to start thinking differently. We have to come up with new business models. And I think actually COVID can be a catalyst, as you use the term, to really accelerate some of that innovation. And the sustainability, for me, makes that even more important. Taking Vivek, we can't afford to wait. We need to do this now, and we need to accelerate it. So a broad answer, but partnership, collaboration, initiatives from government, support in terms of core funding, but we also need to bring in that public sector, private sector funding to really leverage this to create commercial difference going forward.
Okay, thank you, James. That's a good point. Rob, I'm going to pick on you actually, because you are the most senior scientist amongst us. So James, it's this push and pull, and it's the context. So now you mentioned a couple of contexts we just picked. You mentioned COVID, we mentioned Brexit. It takes something to accelerate what we do, how we respond to things. Graphene was curiosity, penicillin was curiosity, the example you made, and scientists just thinking about it in labs and come up with something really exciting. Then I think you said 15, 20 years was the lag between it actually being put into market because of the Second World War. Is there something here about scientists? Do they need to be thinking a little bit more ahead? Do they need to be thinking, actually, when I experiment, this actually could be applied? What's your views on that? Or is that unfair to scientists?
It's an interesting question. I mean, I think when times are tight and funding is limited, there is an innate Britishness that forces everything to become more and more conservative. It's actually the antithesis of what we need. Now is the time when we need bold thinking. Now is the time we need creativity. Don't forget, we only put a man on the moon because the US president said we're going to put a man on the moon. We didn't know how we were going to do it at the time, but we need bold leadership and big ideas, coupled with the more pragmatic incremental things to take the steps that companies are comfortable with, that they can see a return quickly. There's financial stress right across the SME sector, right through into the big companies as well. So we need a portfolio of activities here, from the horizon scanning discovery of the academics, which may be longer term, but we also need those people who sit in that middle ground between hardcore commerce and academia, who can spot the ideas and spot the opportunities and build the bridges between the two. And I think this is the kind of opportunity that perhaps we can foresee with the Innovation District Manchester coming forward over the next 10, 20, 30 years, where we will have the academic and the innovation centres right alongside some of those next stage commercial developments. So I think we're in interesting times. Everybody has a part to play, including government, with brakes on taxation in some quarters for sure, but also incentivization by targeting funding to particular global needs. I think it's not a UK specific scenario. We're not going to solve the global warming situation simply by focusing on the UK. So we do need to think about that international context as well.
Thank you, Paul. Actually, if I may go back to Adrian. Adrian, you take a global view with the Nixian Journal, and just that last point that Rob's picking up there, we perhaps over focus a little bit on the UK here, maybe for good reason, and place is important, of course, but how do we compare in the UK perhaps elsewhere? Have we got a chance here, like in Rob's field in biotech and graphene at Manchester? Have we got an opportunity here to take some leadership here globally? What's your view? What would you say on that?
Yeah, it's tempting to run the UK down when you look at what's going on in places like, particularly China, funnily enough. We're seeing a tremendous amount of work, particularly around the concrete stuff. We're picking up now, the Chinese government is sort of pushing people towards experimenting with 3D printing concrete, and we're picking up that graphene is going into that. And it's tempting to say, oh yeah, the UK and the US actually are way behind. However, the stuff that's going on at the moment, I know James Baker at the Geek is lobbying hard to raise awareness of this in the UK amongst the key decision makers that matter, and you may want to talk a little bit about some initiatives that are going on there. There is a huge amount of work taking place at the minute, sort of socializing these ideas, getting acceptance, and getting groups of people together to say, yes, let's get ahead and do this. So there's a huge amount of stuff happening, I see, in the UK under the radar. I think when this stuff really starts to hit and take off, the groups come together, we'll start to see very, very visible signs of activity taking place. And it's due to, in large part, the graphene community, particularly a lot of the work that James does and the team around him about bridging between government, academia and industry. And bear in mind, this material has only been out for since 2004. It's still a teenager, as James says. So we're seeing lots of activity. General public at the minute will probably in about 2 to 3, 4 years suddenly go, blimey, graphene, it's everywhere. Where did that come from? So there are plenty of green shoots there and lots of activity taking place.
Right. Well, that's a very positive outlook. Thanks, Adrian. And now you look at Rob. He's a lovely man. He's a scientist. So, is there an issue, do you think, between you sit outside academia in a way, although you're very much part of our community in some senses. But is there still a view between industry that this is hard? Universities are hard to work with. Scientists are a bit distant. I mean, is that, you talk about this Venn diagram of the mix? Is that changing fast? Is it something that, or could that be accelerated as well? That perception.
Yeah, I mean, if give you one example, just because we're just focusing on concrete at the minute. This is just one small part of the puzzle.
Okay.
You could argue that academics come along and say, okay, graphene makes concrete 25% stronger, therefore you need to use 25% less. So if I was being a bit cynical, I might say, okay, I'm a naive academic going to industry saying, got this great idea, you can use a quarter less or sell a quarter less of your product a year. And that would probably fall on deaf ears. However, listen to what the conversation has been doing actually here so far. Yes, at one level, you might say if you're trying to get, let's say, graphene into concrete, that might be a tough ask. But there's an awareness already in what the speakers have been saying that this is a sort of a little bit of a wicked problem. You need to approach it from different angles. So get the incentives right. Rob talked about this. James talked about government policy coming in. You'll get the behavior you reward. So if you want to start to get people using concrete and get the impact on climate change through global CO2 emissions, then government needs to play its part and make sure that people are rewarded for doing the right things in the right way and implementing these things, helping with regulations, all that type of good stuff. So it's on one level, you might think that academia is quite separate, but the graphene and 2D materials, this stuff is advancing so fast and involving so many people. I think actually it's beginning to sort of steamroller over these traditional boundaries. And generally, I am very optimistic about where all this is going. We just keep on getting the message out, keep on getting the awareness out, and you watch what happens.
Thank you, Adrian. That's brilliant. I might actually start looking at some questions are now coming in, and I might throw those to the panel now. From Peter. How does graphene fit into the circular economy, and can it be recycled itself? I mean, maybe James wants to answer that one first. Yes, can graphene be recycled? I mean, what's your view on that?
So I think Adrian touched on earlier. So graphene, is carbon. It's a form of carbon. So generally we make graphene from several sources, from graphite, as Adrian described earlier. So we take graphite and we break it down into sheets or a few sheets of carbon. But you also take it from a gas, for example, methane or potential carbon dioxide in the future. So Adrian touched on, maybe comment, there's still some processes need to be developed, but ultimately carbon is in the ground, it's in your body, it's in the air. So, taking something like carbon from graphite or from methane, so some producers take food waste to create methane, which you can then take the C out of methane, if you like, the carbon out to create this graphene. So potentially it is ultimately in the circular economy. But then I also look at Vivek's product. He's taking an old tire, chopping up, adding graphene to create a mat. When that mat is worn out or is old, or you want to recycle it, you can just repeat that, cycle that product, add a bit more graphene to go back to its original properties. So as well as the graphene itself being circular, potentially we can get these circular, it can enable circular recycling. Vivek mentioned it. Traditionally, when you recycle a product, you lose a lot of the mechanical or the performance of that product. But by adding advanced materials, if you can go back towards the original performance, it makes the recycled product an attractive alternative. So yeah, I think it plays a big part in this whole recycling and circular economy going forward.
Thank you, James. A question from Jen here. I might have to keep you on here. Sorry. So it's are you no, sorry, hold on. Oh no, actually, Tom. Actually, I've got to do Tom's question next. What are the essential components of regional innovation hubs like Manchester? Actually, that might link into both Rob and James here. Now, Rob, you have a manufacturing hub in biotech, don't you? At MIB. So that sounds exciting. That's a hub and spoke model. How do you feel about this place and this regional innovation? Are you confident in that?
Yeah, I mean, I think this is absolutely the way to go. I think looking at somewhere the size of the UK, we can't have everything everywhere. We need exemplars. We need examples of where we've built it, and they will come, I suppose, is the way to look at it. And whether that's on the graphene side or on the biotechnology side, I think Manchester is very well placed in this regard. I think the hub and spoke model is attractive to government because it's demonstrating that we're not an ivory tower sitting in the middle of a city and paying no attention to what goes on elsewhere. The Northwest and the Northeast have a very substantial agricultural economy. one that is indeed complementary to the activities that we've heard about today. And I think they both have an incredibly important role to play as we go forward. So I think it's important that we join up what is traditional farming activity, if you will, and industrial activity on the other side. So a melding of the dark satanic mills and green and pleasant land, I suppose, if you will, to see where we go going forward. And it's greener and more pleasant for all concerned.
Fantastic. Yes. So the North reinvents itself. And James, I've often heard you talk about a Manchester model. So I know and you talk about Manchester as the home of graphene, etc. Place is very important in that narrative. That must be a good thing, I guess, especially for regional innovation.
Yeah, I mean, for me, place is very important. But when we talk about place, building what Rob said, it's about distinctiveness. Yeah, we're not trying to create Manchester as an example the same as Oxford or Cambridge. Oxford and Cambridge, as an example, have their strengths. The University of Manchester has its strengths. It has 5 what it calls beacon areas. One of those is around advanced materials, and it's been recognised through the creation of the Royce Advanced Materials Institute that's centred in Manchester, but involves 8 other universities across the UK. So it's not about repeating, it's about leveraging the strengths. We work closely with the Catapult organisation, so things like the Advanced Manufacturing Research Centre in Sheffield, National Composite Centre in Bristol, the Centre for Process Innovation in Durham, just to give you a few examples. So for me, it's about leveraging that capability across the UK, which probably comes back to government intervention, the role of companies like Innovate. Beanish has been very successful in winning a significant grant from Innovate UK, which enabled her to bring a focus in Manchester, but she's also working with partners across the Northwest, across the Midlands. So for me, the place is important, but it's about how we establish the links. I mean, there's another question about talent from London. I think,
yes, exactly. I know.
Place is important, but we need to bring physical things together at times. But actually through Zoom and through Teams, we've almost neutralised the fact that traditionally, Manchester is only 2.5 hours. I think we were on the news about 3 years ago. A minister at the time, I won't name him, sort of said he had to take a helicopter from London to Manchester because it was a bit too inconvenient to go on the train for 2.5 hours. I think now in this new COVID world, through Zoom and through WebEx, we can be in the UK in the morning, we can be in America in the afternoon, we can be in Asia the following day, virtually, of course. So I think place is important, but it's about leveraging capabilities and more important.
Very good. Yeah, I agree with that. Okay, that's a good point. Okay, a technical question here, and I don't know who's best placed to answer this at all, really. Is there any other technology being applied in construction materials, I suppose, other than graphene? I don't know there's a biotech answer to that, Rob, but it's an interesting question. I suppose the answer is yes. What that would be? Anybody can throw in on that one at all? Adrian, maybe you might. You're quite. You're
I have heard, well, it's not graphene, but I have heard, and Rob will know probably more about this than I will. Cracking in concrete is a big problem. So by adding bacteria that create like a calcium carbonate shell around them, where you put them into the dry concrete, and when they get wet, they activate and start producing the calcium carbonate again. So effectively, you have a self-healing concrete, because when the cracks occur, lets the water in, the bugs get going. I don't know if you know any more about that than me, Rob.
And not that one specifically. I think there are a lot of activities in that general space as to how we can harness organisms that are already out in the environment. So there's no GM angle on sort of this to produce materials that complement some of the harder materials we might use. Another example, certainly one from Manchester, is current work looking at spider silks and how we can produce them at scale without using spiders. And also with that, to look at the structure and property relationships of some of those materials by looking at a much wider range of species of spiders without ever going near a spider. So it's providing different ways to access tunable properties in materials, I think, from the biological side, whether that's coming from crop plants or whether it's coming from bacteria or fungi, or indeed from seaweeds. So there's a lot of opportunities to complement those renewable feedstocks with the concretes and so on of this world, for sure.
Wow, that's an amazing, interesting collection of feedstocks there from all sorts of materials. That's quite interesting. And then there's an interesting question here actually, and I look at this to the panel actually as a whole. So as a consumer, says Giganta, will I see industry-wide adoption of durable graphene in footwear from major sporting brands to luxury goods? And then interesting, the point being made here, will that mitigate fast fashion? The durability of the product, will that mean we have less landfill? I mean, that's something I think Vivek's been involved in a lot, and that avoidance of landfill and recycling, etc. But any response to that, Vivek?
I mean, the current question is regarding the shoes. Shoes is also a footwear, especially graphene, long-lasting one. The question. I mean, we don't want anything to go to landfill. So even in the case of shoes, we need to start recycling it. And if you think about UK, more than 70 million people, and it will be a very large number of shoes, and it will end up in landfill. So we need to reduce that by recycling it. And graphene does help in that, because if you take the old shoes and make it a new, use the sole and make a new shoes with that, you can use graphene to enhance the performance. So yeah, graphene does help going forward to make high quality products.
Fantastic, James. I mean, one example, James Baker. One example that just springs to mind. I don't know if the person there's knowledgeable. There is a graphene shoe, isn't there? There's one. I don't know if you've got one handy to show the crowd here. It never fails.
So for me, it really answers the question. One of our partners has looked to put graphene into the rubber on the sole of the shoe. So traditionally, you have a trade with rubber. You can have a very soft and grippy rubber, but the consequence, it tends to be not very durable. So this is an off-road shoe for fell runners and gives you great grip. But some of the runners, professional runners, semi-professional, will wear the shoe out after 200 kilometers and end up that shoe being on landfill. By adding graphene, they've got a very soft, grippy rubber, but it's also more durable, 50% as a material. Well, that then translates into a shoe that typically can, instead of lasting 200 kilometers, lasts over 1,000 kilometers. So again, just one case study where by adding graphene into a material, we can do that trade. We can get something that's grippy and soft. So if you Google the runners, you're finding they're breaking the records now because they're running up the hills faster. They've got more confidence because of the grip on slippy, wet rocks, but they're now having to buy less shoes and throw them away because they're lasting that much longer. So again, I think it's just a very quick case study there of advanced materials can start to play with the trade. It's a bit like the concrete and the construction example. Carbon fiber, a lot of talk about using carbon fiber, but by adding graphene into glass fiber, you can actually improve the properties of the glass fiber. Again, one of our partners is putting that into swimming pools as an example in Australia, where traditionally you might need a carbon fiber, very expensive, very tough, but by adding graphene into glass fiber, you can actually make a glass fiber structure that's both strong, but it also stops the water from leaching through. So again, advanced materials have this multifunctional property, and where graphene starts to make a real difference, if you can have something that's got both performance properties and durability and life, as well as recycling, you start to really create competitive advantage for your consumer or for your industry.
Thank you. Coming to the last of the questions now. That's so, and here's one actually that kind of reflects what we talked about earlier in this idea from it's anonymous. But do you think we support our universities in the UK enough to let them do the research might eventually lead to the innovation of products? I mean, maybe, I don't know, Rob wants to answer that one, but are we getting that support? We talked about this partnership, between government, local authorities, business, and universities. Is it enough? Or obviously, I suppose you'd like to see more, but how would that happen?
It depends where you want to focus in that question. If you want to focus on the innovative products at the end, there's a gap in the funding opportunity to take the innovative ideas from academia through to products. So there's certainly some shortcomings in that middle ground. Government is talking about a mission-orientating funding agency to emulate what they have in the US to bridge that valley of death. From the discovery side, there's always plenty more discovery one can do. I think what we've learned over the last century or so is that it's difficult to predict what you need to discover in order to translate down the line. So it's really important that we keep a robust and broad fundamental science base in this country. So more funding into basic science will sooner or later to lead to those products, but it's very difficult to judge which basic science will lead to which kinds of products.
That curiosity issue you mentioned earlier. I might actually, can I go back to Beanish? Now you obviously you had a PhD just a few years ago. You're an early career academic, or you would be an early career academic if you pursue that line. You won an award, so you did get that push. You've had that support as an innovator. The El Harari Award. How did that transform your business opportunity, Beanish?
Yes. So firstly, I graduated from University of Manchester in 2019, and after that, basically, instead of following traditional route to academia, in my mind, I was like, I want to develop some innovative product, and for those things, we need some sort of initial seed funding. And I think Ali and Harari Graphene Enterprise Award helps me a lot, because from that seed funding, I have developed some prototype and we got some results, and that led to win 1.4 million Innovate UK grant. So yes, I'm saying it's quite helpful.
Brilliant, that's great. It's great to hear that case study, and then look where it's led to. You know, within a few years, well, I don't know how long, 18 months of a business, you're landing, quite considerable investment from government to push your idea forward. So I suppose you are that living case study of how we can support science and scientists to innovation. That's fantastic. Actually, I suppose we are thinking about coming to the end of the session, but what I would like to do is each of you just to give Adrian, I'm going to start with, I think, because you are the most optimistic person. Everyone's optimistic here. You are the most optimistic. You're man of the match when it comes to optimism, Adrian. So, future economic, building an economic future that's going to be green and fantastic. Are you optimistic, Adrian? What do you? And are we going to do it in time? What's your view on that?
Yeah, incredibly. I mean, the reason I'm optimistic is I'm monitoring this whole world of graphene and advanced materials every single day to produce a journal every month. Every single month, I'm seeing something that makes me go, wow. And you'll start hearing about this stuff. I think basically, if you've heard graphene is all hype, think again. It will change our world. The pace of change is astonishing. Just to give you a minor example, Ford Motor Company, they've now put graphene in all their cars. It goes into the urethane foams, and these are recyclable. And there are well over 1 million Ford cars on the road today with graphene in them. So if you buy a Ford car tomorrow, it'll have graphene in it.
Wow. Okay. So that's reached that tipping point, I think you're saying there.
Yes, I think that's a very good point, James. Yeah.
Rob, what's your view? Are we going to meet these challenges in time? As a scientist, have we left it too late, or are you confident?
Never too late. Never too late.
Never too late.
There's always a need for more money. There's always a need for more infrastructure. But at the end of the day, it's all about people. And it's fantastic to be on a call with two of those innovative young people who will save us all with a bit of luck. So I look forward to seeing their developments. No pressure, of course.
Absolutely, yeah. That's you. That's Vivek and Beanish. So Beanish, any comments from you? I mean, obviously you got a green future ahead of you. You're very much in the industry there, but you're very confident about your business, I guess.
Yes, so I can see, as he said, it's not too late. Because there are lots of things I cannot discuss due to IP issues, but I can see graphene. I mean, within 2 to 3 years, graphene will revolutionize agriculture and indoor vertical farming system, and I'm mega optimistic about this. Yeah.
Fantastic! It's amazing. Well, I'm just gonna. We're reaching the top of the hour, really, and I think it's been a fascinating session. I mean, thanks everybody here for your contributions and your thought leadership. It's great to see. It is great to see such optimistic views, and it's great to see, like you say, Rob, to see the people like Vivek and being delivering, and the visions from yourself and James there, and Adrian. You got to keep telling those stories more. I mean, it's a fantastic journal, so we'll put that very positive message there. So. Basically, yeah, that's for me, it's been a really fascinating insight into into how we can actually deliver a new economic future. So that's been very rewarding. So yes, just say thank you for me, and hopefully I'll hand over to Elena now.
Hi. Well, my God, that was so fascinating. Thank you so much. I feel slightly like my eyes have been opened to the promise and possibilities of graphene. I couldn't help at one point thinking about my big fat Greek wedding and the father's insistence that Windex would fix everything. I hope that graphene has much more potential and possibilities than that of Windex. But it's been such an amazing morning. What have we learned? There's been so many interesting conversations and insights and tidbits of knowledge. I've been kind of going, oh, wow, I never knew that many times. I think we've underlined every single session that we really need to be looking at collaboration and partnerships. And we need to be bringing together academia, policy, our amazing young entrepreneurs and innovators who are out there trying every day to put their products into market and to scale them and build them, and also with our funders and government. There's a lot of work to be done. It is our pleasure, as always, to host these conversations with us here. You can, of course, catch up on any of the conversations that you might have missed looking on our site, cogx.co. Do sign up for membership. There's a gold membership that is currently being offered free with no further commitment. And if you do that, you can see everything that's gone in the past. And I hope also that you'll join us again next week, because next week we're looking at what's next for the NHS. It's going to be a fascinating discussion. We have some extraordinary people joining us, and do look out for that now. But it just remains for me to thank you all for tuning in, and I hope you come and join us again next week. Thank you so much.